Okay, so now we have an idea that propositional logic uses propositions and that there are certain operators, right? Negation, conjunction, conditional, disjunction, and the biconditional. Those are the basic ones. You have to memorize those. But what we also talk about was what's called well-formulated formulations, right? Or WIFs for short. And a WIF is basically there's certain right ways of writing and combining propositional logic using the operators, and there are also other ways that are bad. Now, some things we're going to introduce, this is where it's kind of like algebra, is we can talk about parentheses. Parentheses will allow us, we can use either parentheses, right, these squiggly lines or brackets, to really separate WIFs. Now, the thing you have to keep in mind here is that the only operator that can operate on one variable is negation. Everything else always has to be connected, right? So let me give you an example, right? If I say not T and not W, that makes sense actually. Why? Because the negation always only works on the thing that follows it immediately afterwards. So in this case, the not refers to that, and this not refers to the W. And the primary element of them all is this guy right here. And in this case, it's a conjunction, right? So this is actually a WFF. This makes sense, right? But let me show you another one that doesn't work, right? Not TW, right? This doesn't make sense because there's no connective, or there's no operator that makes sense of these two statements, right? We need a way of relating the statements together, right? So this is not a WIF. It doesn't make sense at all, right? But we can use parentheses to talk about that, right? Such that we might say, for instance, let's do another example here, right? This is right. You could say you have T and W, then R, right? You could do this, right? This makes sense because this is saying you have T and you have if W, then R, right? So let's say, for instance, it means something like this, right? It's time to go, and if it's winter, then you're going to need a coat. Maybe something like that, right? But that's how we would represent it. This is well formulated. In this case, because everything makes sense. Now, ask yourself, in this particular statement, what the primary operator is. And just like algebra, you always begin with the premises and work your way out. The primary operator is actually this guy right here. And we're going to learn more about this later, but it's going to become pretty important. At the very core of propositional logic is your ability to create well-formulated propositional statements, but also to be able to identify the primary operator that's at stake in them. Right. So let's take another example. Right. You could say C then M then U. Right. This actually makes sense because what you're saying is that the truth value of this, if you have that, then you have this, right? So it'd be something like, if you have Chris, then you have Mark. And if you have both of those, then you have Upton Sinclair, or something like that, right? Let me give you another one here, right? Let's say we have W and U, then T, then L, right? Is this a well-formulated formulation? No, it's not, right? Because here you're saying if you have U, then you have T, then you have L. That doesn't work, right? You need to separate it off. And so what you can do to make it is you can add a parentheses here, right? A parentheses within a bracket. And then it would be well-formulated. Because here you're saying if you have U, then you have T, and if that's true, then you have L, right? And then you have W. So then the question is, let's assume we have a well-formulated one like this. Which one's the primary operator? Remember, if you always start with your premises and you work your way out, you're going to say the conditional is because it's the last thing you've worked your way out. In the same sense of algebra, you always begin with the premises and work your way outward, and the primary operator will be the last thing. And the reason it will become important is because that's how you determine the truth value of the statement given. So I think at this point, you don't have to worry so much about the primary operator, but what you do need to be worried about is formulating these correctly. Let me give you another example. Right? Let's say we have B triple bar T is that a width? The answer is no, because the negation doesn't refer to anything, right? Is this a well-formulated? Yes, because this you're negating the biconditional B to T, right? So yeah, you're going to have to work on practicing and recognizing well-formulated propositions and ones that aren't well-formulated. And so that just kind of requires practice, but ultimately you'll be able to do it fairly well. The rest of the chapter in this lesson basically introduces you to some translation strategies for translating ordinary language arguments into the propositional form. Really with those you kind of just need to read the chapter and then just do your homework and just practice it. Like anything else, this is just going to require practice and practice and practice. But you will find that propositional logic really offers us an extraordinarily rich medium for deducing extraordinarily complex arguments in terms of their validity and whether or not the arguments are cogent. So I think you'll find that it's pretty exciting, and if you're like me, I think that this is more interesting than the categorical syllogisms, but we'll see what you think. Okay.